Gear trains. A gear train is a combination of gears used to transmit motion from one shaft to another. It is typically required to achieve large speed reduction within a compact space. Simple gear train. A series of gears capable of receiving and transmitting motion from one shaft to another, where all gears axes remain fixed relative to frame, and each gear is mounted on a separate shaft. Train value number of teeth on driving gear by number of teeth on driven gear n5 by n1 is equal to t1 by t5. Say speed ratio 1 by train value. A simple gear train can also incorporate bevel gears. A pair of mated external gear always rotate in opposite directions. All odd number gears rotate in one direction while all even number gears rotate in opposite direction. Intermediate gears have no effect on the overall speed ratio and are therefore known as idle or compound gear trains. When a series of gears are connected in such a way that two or more gears rotate about the same axis with identical angular velocity fixed to the same shaft, it is known as compound gear trains. Train value product of number of teeth on driving gear by product of number of teeth on driven gear. N6 by N1 is equal to T1 into T3 into T5 by T2 into T4 into T6. Reverted gear trains. If the axis of the first and the last wheel of a compound gear train coincide, it is called a reverted gear train. Such arrangements are widely used in clocks and simple lathes where a back gear is utilized to provide a slow speed to the clock. Train value n4 by n1 is equal to t1 into t3 by t2 into t4. If r represents the pitch circle radius of a gear, r1 plus r2 is equal to r3 plus r4. Epicyclic gear train. When there exists a relative motion of axis within a gear train, it is called an epicyclic gear train. Thus, the axis of at least one of the gear moves relative to the frame. For an epicyclic train with a Sun wheel S, planet wheel P, and an arm A, assuming clockwise motion is positive and counterclockwise motion is negative, if arm A is fixed and Sun wheel S turns through X revolution clockwise, revolution made by arm A is equal to 0, revolution made by Sun wheel S is equal to X, revolution made by planet wheel P is equal to minus TS by TP into X. Extremely large speed reductions are possible with epicyclic gear configurations. In general, epicyclic gear trains possesses two degrees of freedom, sun and planet gears. So when an annular internal wheel is added to an epicyclic gear trains, the combination is usually referred to as an sun and planet gear systems. The annular wheel A meshes with the planet wheel P, which can rotate freely on the arm A. The wheel S and P are called the sun and planet wheel respectively. Case 1. If the sun wheel S is fixed, NH is equal to 0, NA by NA is equal to 1 by TS by TA plus 1. Case 2. If the annular wheel A is fixed, TA is equal to 0, NA by NS is equal to TS by TA 1 plus TS by TA. Differential gear. When a vehicle takes a turn, the outer wheel must travel a farther distance than the inner wheel since both rear wheels are driven by the engine's through gearing. An automatic device is required to allow the two wheels to rotate at slightly different speeds. This is accomplished by a differential gear on the power axles. The differential gear acts as a device that adds or subtracts angular displacement seamlessly.